In this video, we'll take you on a journey through the history of table tennis and dive into the material selection. We'll explore three materials and determine which one makes the perfect table tennis racket. So, let's get started. Let's take a quick journey through time to understand the evolution of table tennis, a game that has transformed significantly over the centuries. Did you know that table tennis, or ping pong, is originated in the 19th century in Victorian England? Back then, it was a parlor game played with the simplest of materials. People used everyday objects, like matchboxes as paddles and corks as balls. It was an improvised version of lawn tennis, designed for indoor entertainment. Fast forward to today, and table tennis has become a globally recognized sport with advanced equipment. The paddles we now use are carefully designed, combining different materials to enhance performance. The balls, once made of cork, are now made from ABS plastic for better durability and consistency. Now, let's break down the components of a modern table tennis racket to understand why material selection is so crucial. At the core, we have the blade, typically made of soft wood. This provides the essential structure and strength. Covering the blade is a thin layer of rubber, often pimples in or pimples out, depending on playing style. This layer controls the spin and speed of the ball. Between the blade and the rubber is a sponge layer. This adds elasticity, helping players achieve better ball control and powerful shots.
Now that we know the history and components of a table tennis racket, let's move on by looking at the key properties that makes a racket truly high-performing. There are 5 main properties we need to consider when selecting the best material, which are density, elasticity, abrasion resistance, water resistance, and cost. First up, density. Density is determined by how much energy is absorbed when the ball hits the racket. A higher density would indicate that less energy absorption occurs, leading to better ball deflection. This is measured in grams per cubic centimeter. Next up, we have elasticity. This property stores potential energy during the impact. Greater elasticity means better kinetic energy transfer, helping you deliver more powerful shots. We measure this using the modulus of elasticity in gigapascals. Abrasion resistance is crucial because it prevents wear and tear from constant contact with the ping pong ball or table tennis ball. Higher abrasion resistance indicates that less damage is taken and has a longer lifespan. This is tested by simulating surface wear under friction. Next, water resistance ensures that the racket can withstand moisture, especially in humid conditions or during intense matches where sweat is present. Higher water resistance means better preservation of the materials and is measured by checking water absorption of the material after prolonged exposure. Finally, cost. This determines the overall lifespan and quality of the racket, as higher cost materials often provide better performance and quality. This is assessed by the cost per kilogram of the material. Understanding how these properties work will help us to compare our 3 main material choices effectively. Let's see how each material measures up. So, the 3 material choices we're evaluating are natural rubber, thermoplastic polyurethane, and cork oak. First, we have natural rubber. It is produced by collecting latex from rubber trees and then processed in factories. Natural rubber is widely used in products such as surgical gloves, toys, and many more due to its flexibility. Next is thermoplastic polyurethane, or in short, TPU. This material is created through a polyaddition reaction involving 3 main ingredients: polyol, chain extender, and dissocyanate. You'll often find TPU in sportswear and wire or cable jacketing because of its impressive elasticity and resistance to wear. Finally, we have cork oak. This material is cut or peeled from the outer bark of cork oak trees. It is commonly used in bulletin boards and bottle stoppers because of its lightweight nature and water-resistant properties.
Let's now compare the three materials side by side based on the key properties we discussed earlier. This comparison will help us determine which material is best suited for our table tennis racket. Starting with density. Natural rubber has a density between 0.92 to 1.1 grams per cubic centimeter, which means it offers moderate ball deflection. TPU has a higher density, ranging from 1.28 to 1.66 grams per cubic centimeter, which may provide better ball deflection. Cork oak has the lowest density at 0.86 grams per cubic centimeter, which could result in poor energy transfer. Next, elasticity. Natural rubber offers low elasticity, between 0.0015 to 0.05 gigapascals, providing limited energy return. TPU stands out with elasticity ranging from 0.621 to 5.5 gigapascals, making it the most elastic material. Cork oak, however, has the lowest elasticity at 0.028 gigapascals, which may not give the best performance. In terms of abrasion resistance, natural rubber has moderate resistance, meaning it can withstand wear but may degrade over time. TPU performs well with good abrasion resistance, which is ideal for long-term use. Cork oak, however, fares poorly here, as it lacks strength under friction. Next, water resistance is crucial to prevent damage. Both natural rubber and TPU have good water resistance, ensuring longevity in various conditions. Lastly, although cork oak has decent water resistance, it is highly sensitive to humidity changes. This can cause it to warp or deteriorate over time in environments with fluctuating moisture levels. Finally, the cost. Natural rubber is affordable at 10 ringgit and 87 cents per kilogram. TPU varies between 8 ringgit and 94 cents to 17 ringgit and 87 cents, offering a range of options depending on quality. Cork oak is significantly more expensive at 60 ringgit and 14 cents per kilogram, making it less economical. Based on this comparison, it's clear that one material stands out in terms of performance and cost effectiveness. Let's see which one is our final choice. After analyzing all the key properties and comparing the materials, we've chosen thermoplastic polyurethane or TPU as the ideal material for our table tennis racket. Now, here's why. Firstly, TPU offers high density, ensuring better ball deflection and energy transfer while still being relatively lightweight for comfortable handling. It also boasts excellent elasticity, allowing greater energy return and a better transfer of kinetic energy during the play. This translates to more powerful and responsive shots. Other than that, TPU's good abrasion resistance means it can withstand wear and tear from constant ball contact, enhancing the racket's lifespan. With good water resistance, TPU protects the racket from moisture damage, making it reliable even in humid or damp environments. Lastly, TPU is cost effective, offering a great balance between performance and affordability, making it an ideal choice for mass production.
Now that we've selected thermoplastic polyurethane, TPU, let's explore into how it is produced and processed. First and foremost, TPU production begins with the mixture of three key components: polyol, methylene diphenyl diisocyanate, and 1,4-butanediol, BDO. This combination forms the base material for TPU. The mixture is then heated to produce molten TPU, which is extruded into strands. These strands are then cut into pellets, making the raw form of TPU. These TPU pellets are very versatile and processed using several methods to create different type of materials. These processes include injection molding, compression molding, and 3D printing. First up, injection molding. TPU is melted and injected into molds under high pressure to create precise, detailed components for various applications, ensuring durability and consistent quality. Compression molding is where molten TPU is placed into a mold and compressed under heat and pressure to form a thin, uniform sheet or shapes. This process is widely used for creating durable, elastic products such as flexible films or protective layers. Lastly, 3D printing is where TPU is melted and deposited layer by layer, enabling the creation of complex, customizable designs for applications ranging from prototyping to advanced manufacturing. When it comes to table tennis paddle rubber, compression molding is particularly important. TPU is heated and pressed into molds to create thin rubber sheets with the desired elasticity, thickness, and surface texture. These sheets are then laminated onto the paddle blade, providing the grip, spin, and control needed for high-performance play.
As we conclude, let's take a moment to address the long-term sustainability and socio-economic aspects of our material choice. Firstly, we have raw material origins. TPU production traditionally relies on petroleum-based raw materials. However, advancements in technology are paving the way for bio-based alternatives, such as using soybeans as a renewable source for TPU manufacturing. This shift reduces our dependency on finite fossil fuels and aligns with global efforts for greener practices. Secondly, we have carbon dioxide as raw material. In TPU manufacturing, supercritical carbon dioxide can now be utilized as a foaming agent to produce lightweight TPU foams. By subjecting carbon dioxide to high pressure and temperature, it not only reduces the reliance on traditional raw materials, but also improves the material properties, such as compressive strength. This innovative approach repurposes industrial carbon dioxide, contributing to a reduced carbon footprint and promoting sustainability. The next aspect is recyclability. TPU is thermoplastic, which means it can be melted down and reprocessed, making it a highly recyclable material. This not only reduces waste but also contributes to a circular economy, where resources are reused and repurposed instead of discarded. Lastly, we have economic and social impacts. By investing in greener manufacturing facilities and bio-based TPU, we create opportunities for economic growth while addressing environmental challenges. Such innovations can support job creation in sustainable industries and contribute to the well-being of communities.
Thank you, Sharon, for that brilliant sharing. To conclude, our material selection process has carefully considered not just performance and functionality, but also long-term sustainability and socio-economic impacts. TPU stands out as a versatile material, offering excellent mechanical properties, recyclability, and the potential for a bio-based production. By prioritizing greener manufacturing processes and embracing renewable resources, we not only address the immediate need of our project, but also to contribute to a more sustainable future. This approach ensures that our solutions align with global sustainability goals, foster economic development, and uphold environmental responsibility. With TPU as our choice, we demonstrate that innovation and sustainability can go hand in hand, paving the way for an impactful and lasting change. Thank you for listening to our presentation. And yeah, this is our list of references.